The goal of this lesson was to describe variability in context. So variability meaning, if you look at these mile times in this context, the numbers are not all the same. The runners came in at different times. So rather than trying to describe a typical runner, which was a previous goal using measures of center, this time we wanted to be able to describe how different they are, so measures of variability. So we'll look at some classic measures of variability in this lesson. So the first thing you should always do is make a graphical display. And so the directions here ask you to make a dot plot or a stem plot. Those would be two kind of quick ones. And by doing that, you'll see that there is a long drawn out left tail, at least compared to the other part of the data. So the shape of the data would be skewed to the left. That way you kind of have a picture of what kind of data you're working with. So the first measure of variability that you'll calculate is the range. And so for this data set, you should still carry this out, but you'll get 1.38 minutes. It's the largest value minus the smallest value. And more important than the number itself is the interpretation, because the directions say, can you write a sentence that uses the range? So describing variability using the range, you would say something like this, that the mile times were spread over a range of 1.38 minutes. So notice I used the word range in my sentence, and I linked it to being a measure of spread or a measure of variability. And I cited the specific number that it was associated with it. The interquartile range, reading through the directions here, it's the spread of the middle half, or literally the range between the quartiles. So you find the third quartile and the first quartile and subtract them. And doing that, you'll get an answer of 0.89 minutes. And again, using this number in context, what does this actually tell you about the data? So we'd say the middle half of the mile times was spread over an interquartile range of 0.89 minutes. It kind of gives you a sense for what that middle half or that middle group is doing, that they're all within about a minute of each other. And then finally on the back, we're building towards the standard deviation. And all of this stuff on the back is building towards that. So first you need the sample mean. And we start looking at, for each value in the data set, each number in the data set, we look at the deviation from the mean. And there's a note up here that deviations can be positive or negative. You're supposed to take the value from the data set, subtracting the mean. So if the value is above the mean, it'd be a positive number. And if it's below the mean, it'd be a negative number. And we'll notice once you do this that these deviations, because some are positive and some are negative, just a property of the mean, they will always add to 0. So because of that, we deal with the fact that they always add to 0 by squaring them, because squaring numbers always ends up being positive. So you get all of these positive numbers that are squared deviations from the mean. And kind of following the directions here, if we describe a typical squared deviation from the mean by adding them up and averaging them, and there's a little note about dividing by n-1 here, so read that carefully, you'll see that the sample variance, which is the average of those squared deviations, is 0.2025 minutes squared. And I'm not going to try to focus on how to interpret that because the units in the context is strange, but instead of doing a squared deviation, we square root and we get the standard deviation. Square rooting 0.2025, you get 0.45. And so finally putting that in a sentence, that's a powerful number to be able to communicate. So you'd say, based on the standard deviation, typical mile times for these runners were within 0.45 minutes of the mean time of 6.37 minutes. So you kind of have this sense for a typical runner based on the mean, on average, was 6.37 minutes, but they weren't all 6.37 minutes. In fact, probably none of them were. They were just close to that. And the 0.45 gives you an estimate for how far the typical runners were away from the mean. And finally, a quick note about notation as you close this. There's symbols that are different for samples versus populations. And so if you kind of go back, read this notation box, and then go back and notice that these were embedded throughout the lesson, especially on the back here. The sample mean, the symbol is X with a bar over it. We call it X bar. The standard deviation just gets S. And so the variance doesn't even get its own symbol. It's just S squared. So those are the main measures of variability that we're going to look at. We've got the range, the interquartile range, the variance, and the standard deviation.